I've been trying to figure out what the best way to show this project is. Very simply, it is a motor driver. Very basic DC motor and a thumb trigger. So you see, push on the trigger, the motor goes. Sounds very basic, but of course, as soon as you dig into it and you actually start trying to put it together, it gets quite complicated. I'm going to go over the main components first, and then I'm going to talk about how you can put them together. We have a battery. It is a 24 volt, 10,000 milliamp battery. We have a motor controller. We have an Arduino, and we have a thumb drive, and of course the motor itself. The first thing we're going to talk about here is this battery. Basically, it's going to come with two just regular wires. You're going to have to strip the wires and add connectors yourself. I've included a link to the connectors. But basically, if you touch these two wires together, you will short the battery, and there will be a spark. You can actually see it's a little bit black. I did that. Don't do that. This is very dangerous, working with just exposed wires and everything. Don't do this at home, of course, but if you want to do it at home, the links to everything are in the description. But yeah, as soon as you put these crimp connectors on here, you need to have something to cover at least one of the terminals. So I just have another dead wire. Very unlikely to cause an arc as long as I close this. Alright, so just put male connectors on the battery. Yeah, and that's enough for the battery for now. Now let's talk about this motor. The motor is not as dangerous, but DC motors like this, they can work two ways. They can work as a motor or a generator. So if you apply current to these leads, it will spin the motor. If you spin the motor, it will apply current to these leads. Okay, so keep that in mind. If you have this, connected to some kind of machine, and you are turning this sprocket, it is going to generate a current on these wires, and you could get shocked just as easily as you could with this battery. We don't really have to worry about that with this project, but yeah. Anyways, you're going to have to do the same thing. You're going to have to strip these wires and apply some little male crimp connectors. Okay, here is our motor driver. It is a solo 60 amp motor controller. It's going to come with 4 high power leads. The red and black are power and ground. Those come from your battery. And the green and yellow are your output to your electric motor. Okay, that's the high power side. The low power side has a USB connector that we'll use to connect it to the computer and set this thing up. And then it has pins 1 through 10. In this configuration, we're only going to be using pins 1, 3, and 7. Okay, pin 1 is a ground. Pin 3 is our S1 output. Our S1 input. This is what's actually going to be receiving the signal from the Arduino. And then pin 7 is just a 5 volt power that we're going to be using to power the Arduino. To set this thing up, what we're going to do is we're going to connect it to power and then plug it into the computer. It does not have its own power, so we need to wire up the battery and connect it to this thing before we can actually set it up. So I'm going to show you doing that. First things first, let's connect this battery. You're going to connect red to red, black to black. I'm going to go black to black first. And be warned, when you connect this, it's going to be like connecting a car battery. There's going to be a little spark on the terminal. So when you push it together, just be prepared for the spark and just connect it. Alright. See, we have our little green light, so that means it has power, and now we can plug this USB into the computer. I'm going to insert a little clip of what you're going to need to do from the computer screen. It's very simple. You're just going to connect it, update the firmware, make sure it's in RC mode, and then disconnect it. Okay, so let's talk about the Arduino for a second. The first thing we have to do with the Arduino is we have to connect it to the computer and initialize the code. We have to basically, import the code that is going to operate this thing and control our thumb drive. So let's do that now. You connect this. You'll see that the USB for the Arduino does supply its own power, so you don't need to worry about connecting it to the motor driver or the battery or anything like that. I'm going to insert a little clip now of the computer screen of what you're going to do. Very simply, you're just going to copy and paste the code that I put in the description. You're going to compile the code, and then you're going to upload the code. Very simply. Once you've done that, you can disconnect the Arduino. For a second, let's talk about the thumb drive. The thumb drive is basically just a potentiometer. So it's a variable resistor. You don't really need to know too much about this. You just need to know that the red wire goes to the 5-volt pin, the black wire goes to the ground, and the white wire, our signal wire, that is going to go to A0, pin A0. Okay, now that we've got our Arduino set up and our motor controller set up, we're going to connect the two. Very simply, we just have 3 wires to connect. We have positive 5 volts that's going to power the Arduino. We have a ground cable, and then we have our signal wire that's going to be coming from the Arduino into our motor controller, which is actually going to be acting as the throttle input. Okay, so pin 7 is the VN. That's our plus 5 volts. We're going to connect it to the VN pin on the Arduino. Pin 1, the green wire, that's going to go to our ground. And now you can see the Arduino lights up. It has power. And then this red pin, pin 3, we're going to connect to pin 9 on the Arduino. And that is our pulse width modulation signal. You can see that the motor driver has started flashing on S1. That's good. That means it's indicating a signal being transmitted over channel S1, which is our RC, or our pulse width modulation channel. So the last thing I'm going to do is connect the electric motor. So you can kind of just connect this however you want. If you flip the polarity, it will just reverse the direction of the motor. But the way it's supposed to be hooked up is green goes to positive and yellow goes to negative. Okay, be careful when you do that, because if anything has gone wrong and there is a voltage being applied, this motor is going to spin, and you know, it's got quite a bit of inertia. It's going to thrash around. It could hurt you. Be ready to unplug it. In my case, it hasn't done anything, which is good. It should only move when I push this trigger. So let's go ahead and try. You see it's variable speed, controlled by my thumb drive. And it's sort of unsafe to be operating this motor not bolted down. You can see it wants to lift up off the ground. That's just from the inertia of the motor itself moving. Okay, so that's it. I mean, really it's not that complicated. You just have your battery, your motor. You have the controller that basically distributes that power. And then we have our thumb drive circuit. It's taking an analog signal, translating it to a pulse width modulation signal, sending that to the controller, and that's our bridge between the two. This controller actually does have the capability to do regenerative braking, which I plan on using in the future. Right now I don't have it because we will have to change this circuit to be able to accommodate regenerative braking, because under regenerative braking you have to have a specific circuit to allow for residual braking current to be able to return to the battery, or else it has nowhere to go, and it can be quite dangerous. So we'll do that in another project, but for now, here is our motor driver circuit. All right, thanks for watching.